So today I'm gonna give you the example, the application of cross product. And now let's look at what we have here. So basically we have now three-dimensional space. So we have the x-axis. This is the x-axis. And then we have the y-axis and z. So we have three-dimensional space. And let's suppose we have now three points. Let's call the first one A. So it's located at 1, 1, 1. And the second point, it's B. Let's have its location, for example, 3 to 4. And then the third one here, it's C. So the location of C is 5, 7, 10. And let's have another one, for example, D. So we have 4 points here. We have 4 points, A, B, C, D. And this located at 4, 8, 11. So they are randomly located in the three-dimensional space. Now, when we have 4 points like this, we can now make 3 vectors. We can have a vector from A to B. Let's call it AB. And then we can have another vector from A to C. Let's call it AC. And we can have now a vector from A to D. So let's call it AD. So what happens is like this. When we have now three vectors, yes, 3 vectors. So we can create a three-dimensional shape named Parallelepiped. So that's the name of this three-dimensional shape made of 3 vectors. So let me now show you this parallelepiped. So essentially, from the 2 vectors here, for example, okay, AB and AC, you can get parallelogram. So that's the 2-dimensional space. And then when you think about the last vector AD, so that makes actually the thickness. And what we have is now a 3-dimensional shape like that. So this 3-dimensional shape here is called parallelepiped. Now the question is now, how can we now calculate the volume, of parallelepiped? So it turns out the volume of parallelepiped is given by this nice simple formula where essentially first you do a cross product between 2 of them, for example, cross product between AB and AC. And then after that, we will now do a dot product with the last vector. So in this case, AD. Now, sometimes you can get a negative value from this calculation, and therefore we just need to put the absolute value. So now, if we have 3 vectors, again, AB, AC, and AD, and then you need to get the volume of parallelepiped made by these vectors, you need to do a cross product between 2 of them, AB cross AC, and then do a dot product with AD. So let's first get these vectors first, yeah? The first one is AB, and you know this is just the location of B minus A. And then AC. And lastly, AD. So first of all, I'm gonna do a cross product between AB and AC, and you know how to do this. Essentially, we are making a matrix, and let's now put AB here, and then AC. And then after that, we copy the first two columns. And then we'll do this diagonals now. And after that, we subtract by these diagonals. So what we get is, okay, 18i minus 18i, they are now gone. So we have 0i. And then 12j minus 9j, that's 3j. And lastly, 6k minus 8k, that's minus 2k. So essentially, we got a three-dimensional vector with the first component equal to 0, and then the second one equal to 3, and then the last one is equal to minus 2. Now, what you do is you need to do a dot product between this vector with the last vector, which is AD. So that's 3, 7, 10. Now, we remember how to calculate the dot product before, yes? So 0 times 3, and then plus 3 times 7, and then plus minus 2 times 10. Yeah, in this case, we get 21 minus 20, which is a positive number. So in this case, we will just use this value. We don't need to put the absolute value because it's already positive. So in this case, the volume is equal to 1 unit of volume, right? Thank you.